What up, and welcome. This is Matthew, the designer. Today, we're talking about programming fundamentals. All programming languages are essentially the same. They adapt to certain way of doing things and certain conventions. This adaptation makes it easier for us as programmers and software developers to easily learn them and quickly understand them, even though they have got minor differences. So, let's get into it. All programming languages have got variables. What is a variable? A variable is a small storage space inside a computer. We generally declare a variable in programming. Declaring meaning that creating it or letting the computer know that we want it to reserve this space. Variables have got variable names. It means that if you are asking the computer to help you with reserving a certain small storage space for storing something, you need to give a name to it. So we've got variables and also we have variable names. Let's make an example where you will have to declare a variable. Let's say we have a program that accepts the student number as an input, and then it will tell you which courses the student has enrolled in plus the name of the student. Meaning you will have a text box in your screen to accept the input. When you've got the input, you need to temporarily store it in a variable. That variable will have a variable name stud_num or the full student number. Why stud_num when naming a variable? There are certain conventions for variable naming. Reason is you want to come up with variables that are easy to read and also that are meaningful. You don't have to come up with very long variable name. That's not a good programming practice. So stud_num can work as a variable name and also student number can work as a variable name. Then the computer will create a very small space for you to store the name, the student number, not the name, the student number for that particular student. So when you are declaring a variable in any programming languages, you are asking the computer, Mr. Computer, can you please create this small storage space for me? I want to temporarily save this student number. I will use it later. That will be variables. In any programming language, we have arrays. What are arrays? Arrays are very similar to variables, but they contain certain sections that act like variables. So, in simple terms, I can say arrays are variable with multiple variables inside. However, we don't call those variable inside variables. We just say they are certain sections of an array. These certain sections, we refer to them as numbers or indexes. When we want to access them, we use numbers. In variable, when you want to access that variable, you just use the variable name. That's why variable names must be unique. You are not supposed to have two similar variable names. But in arrays, an array is a container that contains many sections inside it, where you can put different numbers, different information, different string, or different card types. Anything that you want to store there. So the difference between a normal variable and an array is that an array contains certain sections inside. Let's make a real life example. I want to develop a program that is going to store student marks. Instead of declaring, which is creating, asking the computer to reserve space for me, a very small space for all the student names, student variable, Tabo, John, what. I can use an array to declare one array, to ask the computer to create a space for me only for an array. The computer knows that the array has got multiple sections. We need to tell the computer that how many sections do we want, how many storage spaces do we want inside that array. Let's say in my class I've got 56 students. So I'm going to declare an array with 56 students. Then I can put in those sections all the marks for 56 students. It is very important to note that in software development or in programming, there is a phenomenon called zero indexing. Zero indexing states that in arrays or in some certain things in programming, the computer starts by counting at 0, not at 1. This also happens in arrays. A computer with your array indexes, which is then the position of those sections of those small variables inside an array, the computer will start counting them at 0, not at 1. What does this mean? Let's say we've got an array that have got 5 sections and we want to access section number 5. We must use numbers to refer to section number 5. Generally, it's easier to quickly think that if we want to go to section number 5, we just put our array name, open bracket, and put the index number, which will be number 5. Right? Wrong. The computer starts at 0. It doesn't start at number 1. So when it's creating or numbering the section, it doesn't say section number 1, 2, 3, 4 up to 5. It starts counting at 0, 0 indexing. It says section number 0, 1, 2, 3, 4. So your index for the array will end at 4 because the computer starts at 0. So that is called 0 indexing. So we've got an array which is a container that contains certain sections. When you are declaring an array, creating a space in a computer, you tell the computer that this array will have this amount of section. Array that has got 4 spaces, array that has got 56 spaces for 56 students, or array that has got 10 spaces for 10 cars. Those are arrays. Arrays, since they've got multiple sections, we use loops, which is my next section or next point to talk about. We use loops to loop through an array. With that being said, let's get into loops. What are loops in programming? Loops are the means by which a program is able to perform a certain block of instruction repetitively. When a computer is executing a certain block of code repeatedly, we say it's looping. Remember, one of the differences between computers and humans is their ability to perform a certain task all over again without being tired. So computers can be able to loop through a certain group of instructions over and over and over again. So when the computer does that, we are saying that it's performing a loop. If I'm expecting the computer to repeat certain group of instruction, I need to indicate to it where is the loop starting, what is the condition, and when is it ending, or where is it ending. So where is the loop starting and where is it ending? So there must be an instruction to tell the computer that this is the condition that stops the loop. With that being said, let's talk about different types of loops. We've got a do loop. As the name suggests, it first performs a certain group of instructions and then tests for condition. So loops have got an opening part, the group of instruction, and also they have got some sort of a condition where they have to test if is the computer going to continue or it jumps out of the loop. The do loop is structured in such a way that the computer first performs a certain group of instruction, and then after it will ask itself, must I continue or must I stop? For instance, a loop in a real life example. Do these instructions, perform a T, or go to the shop until, maybe let's say, until you find no one in the shop. If you find no one in the shop, then you can stop going to the shop. The difference between a do loop and all other loops is that a do loop has got a certain group of instruction that is going to execute. It doesn't matter if the loop is going to end or the loop is not going to end. You are going to execute this group of instruction for the first time, because it is structured in such a way that it says do first. So a do loop is bound to execute at least once. You will go to the shop. Then after going to the shop, you need to test. Is there a person or there is no one? If there is no one, don't go to the shop again. You can continue and do your own things. If you found someone in the shop, then continue going to the shop. Come back and go to the shop. Come back and go to the shop. So a do loop is bound to execute at least the block of code once, because it's structured in such a way that it says do, that means perform this instruction, and then test after. Then we've got a while loop. A while loop is saying, let's try to be smart. While this condition is met, then you can start to perform the instruction. So a while loop is arranged in such a way that it first tests for a condition before it executes. While there is someone in the shop, then you can go to the shop. So meaning that if there is no one in the shop, then you're not going to perform the instruction. Let's take the while loop and compare it with the previous do loop. Say that you want to go to the shop. You want to test if there is someone in the shop or there is no one in the shop. Let's first take a do loop. A do loop is structured in such a way that you first go to the shop and then you will test after. What if I can have means of calling someone and ask them, are they in the shop or they are not in the shop? The do while loop is saying, go to the shop. It didn't say phone and check. Go to the shop. And then when you are in the shop, you can check if there is someone or there is no one. Then, depending on that, you can stop going to the shop. Even if you've got a cell phone to check the person if they are there or they are not there. But a do while loop is structured in such a way that you must go to the shop. A while loop, first it asks, is there a person in the shop? If there is no one in the shop, it can jump out of the loop without even starting, because it already knows that there is no one in the shop. We've got a do loop, we've got a while loop. There is also another type of loop called a for loop. For this instruction, then do this. I would like to say it's very, very similar to the while loop, but we will get into details of explaining how these loops are unique in another video. The for loop is more similar to while loop, but the syntax and arrangement or the structure or on how it's written is different. For instance, in a for loop, you will have to say for this condition, while this condition is true, then perform this instruction. A for loop is different in such a way that it has got an incremental value, more like a testing value, I can say. In a for loop, that testing value, it's a must. I can say a for loop it can be more used for incrementing instances. For instance, I want to create a loop that will display number 1, number 2, number 3, number 4, number 5, meaning that first round it displays number 0 and add 1 to that number 0, it displays 1. And then on the second iteration, it adds 1 again. incrementing the previous number by 1, then it will get 1, it will get 2, it will get 3, it will get 4. I think a for loop is ideal for that type of scenario, meaning in its own structure it has an incremental number. In its own syntax, you must have an incremental number. You can't have a for loop without an incremental number. So I can say it's more of an incremental loop. It's not like a do while and a for loop for this set of instruction. That set of instruction might be any type of instruction. Do this while that set of condition, while this is not met. That set of condition might be any set of condition. While the user didn't press a button, while the user didn't press space, while the user didn't do whatever. In a for loop, it's more of structured in such a way that it works best on incrementing. For this number that is less than 10, do this. At the end, increment that number. For I less than 10, execute this. At the bottom, before you jump to the top, add 1 to I. Now I is 2. For I less than 10. Is I less than 10? Yes, continue. For I less than 5? Yes. For I less than 9? Yes. For when I is less, or when I is equal to 10, the for loop will start to jump out of the loop, because the testing condition was for I less than 10. As soon as I becomes 10, the for loop jumps out of the loop. So in summary, we've got a do loop, we've got a while loop, and we have a for loop. Any programming language has functions or procedures. What are functions? Functions are just a certain group of instructions that performs a certain task, which is that certain task might be related tasks. Tasks relating to user input, we can create a function for them. We can create a procedure. We can create a block of code that we can use or call at any point in time. Let's say we are working in a project where we are working from different areas, different parts of the world. So we can structure the code or our program in such a way that we've got two functions. Functions that relate to user input and functions that relate to searching. We take one function that relates to user input, we give it to a programmer in different part of the world, and the function that relates to searching, we give it to a different programmer. So the programmer will just create or develop a function that will only accept the input, and then once it accepts the input, it needs to test if is this student belong to a certain faculty or to a different faculty, and it will return the name of that faculty. That's all what it does. However, there is a function that will be responsible for searching, meaning that when this function is responsible for searching, let's say it's searching through an array, a certain number or certain student in an array. So once it picks up those certain students that meets a certain condition, it will return them. Functions, they don't really care much about where is the input coming from, and they don't really care much about where is the input going. They are content with making sure that they do what they are supposed to do. So it's very important when you're creating a function, trying to group a certain instruction that performs similar tasks or activities. When you are grouping them together, you make sure that the function does what it's supposed to do, and also it doesn't serve multiple purposes. You have a function that deals with user input and searching and other things at the same time. So those are functions to group code into a certain block that can be reusable. You can copy and paste it somewhere else, and also it serves only one purpose. Let's just make a real life scenario. Let's say we are working at Facebook. We want to accept the username and the password, and then display statuses that relate or that belongs to that username. we can create that function. However, when we notice that this function is working very well, we can use the same function, copy and paste, and use it for Instagram. Same thing. Accept the username and the password, display post, display statuses, and display statuses that relates to that user. Those are functions, sometimes called procedures. Also, we've got classes. Classes are more like functions, I can say, even though in essence, in technicality, they are not like functions. But for the sake of giving you an idea of where I'm coming from, for the sake of this video, classes are more like function. They also got group of, like they are also a group of instruction, but the way in which they have been arranged, it's different. Classes form part of the object-oriented kind of programming. We will explain that in a different video. For now, I'm just giving you an idea, an overall understanding of what is involved or what is similar to all the programming languages. In object-oriented programming, we've got classes. Classes, they are more like functions because they are just a group of instruction, similar instruction that perform a certain activity. But technically, they are not function if we get into the details, into the core. Let's just make an example. I can make a function that calculates how old are you, or that displays how old are you given your birth date or your date of birth. It will do that. It will check your date of birth, and then it will take the current year minus your date of birth, and then it will get the difference that in this year you are 32 years old. Good. However, if we are solving some sort of, we are trying to come up with a class, we're going to take a totally different approach. And also the problem that we are solving, it's very, very, very different from trying to perform a certain activity. For instance, in terms of a class, or a real life scenario of a class will be, we've got student, we've got animals. Sorry, we've got human beings, we've got animals. Can we create a class of human beings that will have all the characteristics, including functions that belongs or relates to human beings? That will be a class. Can we create a class that has got some properties, that has got characteristics, and also that has got functions of all the things that are involved in a human being? So we will call that class human being. Human being, they've got the name, they've got the age, they've got their race, and they've got their gender. So in this class, we will have all those variables. Those variables will be declared in that class. So we've got a class, human, it has got those variables. These humans, they have got age, how old they are, and the age is determined by their date of birth. The computer can be able to receive a date of birth in a function and then return how old the person is. That can be a function inside that class. How is a class different from a function? Or remember, I said at first that it's more similar. I wanted you to get an idea of, in terms of having a block of instructions inside it, and also some declaration. Now let's try to show you, or let's just uncover the difference between. Now we've got this class of human being and we've got the class of dogs. Obviously, a class of human beings and a class of dogs, they are different because human beings have got a language. Maybe dogs, they don't really have a language, or animals. Human beings can cook, dogs don't really cook. So all the things relating to cooking will be in a class called human, but it won't be in a class called dogs. So how do we use classes? Classes are very, very important in such a way that everything that is inside a class. When you are implementing a class, you can declare a class. You can tell a computer that I want to create this variable. The type of variable is going to be this class. This variable will have everything that this class has. Let's say I declare a variable Matthew, and the type of this variable must be this class, which is human. Why? Because Matthew, the name, or the variable name, belongs to human being. Using that variable name called Matthew in this procedure, I can get everything that is inside that class. That is number one. Using this variable name, I can access everything that is in that class. I will just say Matthew.name. I can store the name, Matthew's name. I can say Matthew.house number, knowing very well inside the class I've got a variable called house number. Then I can store Matthew's house number. However, I can do exactly the same thing and have John, and use the same variable and have Peter and have Samantha. So meaning that when I'm implementing a class, I can have 100 variables declared as that class. If it's declared as that class, it means that these variables are able to access everything that is in that class. No matter how many times I declare that variable, as long as it's gonna be of that class, then it means it has got also access. What is the difference between, where is the game changer here? If we didn't have a class, it will mean that when we are declaring John as a variable, John needs to have a name, a function for calculating the age, the house number, the address number, and everything. When we declaring Samantha, we need also to do the same function, repetition, same function. However, because of we are approaching this from object-oriented, we've got an object called class, an object of human, and then we are instantiating that object, which is we are more of creating it, meaning that we are creating an object called Matthew, or we are creating a variable called Matthew, but this object will inherit all the properties of human class. Obviously, I don't expect this to make sense to you. I don't expect this to be clear from the first start, but however, as we continue with the videos, you will start to understand object-oriented programming, or you can do your own search and search about object-oriented programming, and search about classes, and search about inheritance, and also search about instantiation. Maybe you will get a clear understanding, but this video is for absolute beginners. For me, Matthew the designer, thank you so much for watching. Don't forget to subscribe. These are all the fundamentals of programming. Every language has these things: classes, functions, procedures, arrays, loops. I think I forgot to mention control structures. Let's quickly do that. Control structures are if-else statement. When the computer is executing the program, it executes the program from instruction number 1 to instruction number last. However, in between, it has to make some choices. It's either this or this or that. For instance, if it's raining, don't go to the town, don't go to town. If it's not raining, you can go to the town. That's a control structure. If this, then that. So in computer, we've got control structures, the if-else statement. That means that they are written in this structure. If this variable is less than 2, then do this. If this variable is 4, then do this. If condition, then do this. If statement, they've got another part of them, which is else, which is if it's raining, go to town. Else means that anything else, it's either it's raining, it's cloudy, it's misty, for anything else, then you must not go to town. Those are control structures. They help the program to make decision and make choices. So it's if else statement. If this, then that. So those were the control structures. Otherwise, for me, Matthew, that is it for all the fundamentals of the programming language. Please, 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 if this has added value to you, don't forget to subscribe.